G'day, Michael here. This video is to demonstrate the third method that I wanted to show with this video series. Well, how to design a built-in structure to fit a site. In any case, the outcome is that with CAD, of course, everything fits inside a computer. So physically it's easy to manage the size of an object. But if you want to resolve dimensions in a full size situation, it's impractical, of course, to have a 4 metre by 4 metre drawing board. That doesn't quite work. And an A3 or A4 paper doesn't store much information in real size. So very traditional, I certainly didn't invent this method, but this is going back the old-fashioned way, full-size set-out. Now obviously a full-size set-out, like I said, a 4 metre square drawing area is not practical, but we can encode single dimensions. So rather than dealing with a front view, a plan view, or a section, etc., like you see on a CAD drawing or even an old-fashioned architect's drawing that is to scale, we are going to simply draw each axis or each dimension as we need to. We have here, this first part here that you see is for the width. The second part represents the height. And this portion over here represents the depth. So the one axis, I'm going to say, along the board is the dimension that's critical. The other dimension is just to indicate what all these other bits might mean. So it's more or less a descriptor of what those various parts are. I don't know how well that shows up. Yeah, I probably can see enough. Here you can see the height of the cabinet is compressed, but the only thing that really matters is the depth, and that's represented full size. So if you imagine the whole cabinet just being squashed down, we have the two parts of the kicks, the floor and the top of the cabinet, and the door. Obviously the door is about 2 metres high, so that's definitely not real size. But we have real size when it comes to the depth. So all this drawing is about is simply that one dimension, the depth. This here represents the height. So stand it on the floor and we can see what would really be in height in the space. So we can see that it is, the wardrobe is going to be to about here, and I can see a tangible real size. Okay. And as far as the width, there's a wall here and a wall there, and there's a pair of doors opening here, another pair of doors opening here, and they're the real sizes of those doors. So it's a very tangible, real size thing. Now, this is a very simple cabinet, only a couple of doors, or 4 doors and a couple of cabinets. It's very, very simple. So this set out, it's a bit of overkill, I guess, to some extent, to do something so large with so little information on it. And you probably wouldn't even bother doing a setup for something as simple if you're confident in what you're doing. But if you want to verify what you're doing is correct, this may be certainly a good way of getting a handle on things. Alright, I will go through the process of how this was created, and I'll be doing it in great detail. I'm hoping the pencil lines and so forth that I've used to construct these drawings will be clear enough in the final outcome. I guess let's get to it. Okay, let's get rolling from the beginning. From the sketches, the kick is 100 millimeters from the floor. Okay, so I'm just going to mark that. Add the 16 millimeters, which should also read 116. So basically that's that. That's pretty bang on the right line anyway. Okay. Okay, so there's our floor. Now I'll slide to the other end. Now the ceiling height was nominated at 2400. It is of course important to have this back edge here fairly straight. This was done on the panel saw, so it'd be quite accurate. The bulkhead is 150 millimeters, which of course we can deduct 150 If it's a number that's a bit tricky, you can also go the other way. Start from the 100mm mark of your tape measure so as not to include the end. You can come back 50mm, as you can see. We've got it going there. That concurs, so I'll just get that out of the road. Okay, so that is the limit of our cabinet. So this is the bulkhead, and from here on down is the door. Okay, so what we're going to do now is use the square as a gauge, and follow along with me. The front edge of the door. Now, the door is 16mm thick. It's not essential to make the doors the correct thickness here, because all we're interested in is the height at the moment. Then we need to go 40mm back from that face to match what we had before in the other drawings, and then a further 16. Well, first I'll do that. Let's do that. Now, we're not that fussed with the depth, we're more concerned with the height at this point. Now what we're going to do is indicate that we're cutting that, which is the floor. This is the door, so I'm going to put it right on here, kick. And this here is going to be the floor. So right in here, floor of the cabinet that is. And this here is going to be the door. Now it'll be good to clean these lines we don't need. An eraser will do that job quite nicely. Okay. Carry the rear edge of the door, which is the front face of the cabinet. All the way to the back, up to the top I should say. Oops. Okay, now the top of the cabinet is of course 16mm thick as well. So again, it's not critical for the depth, but the height is critical. We're trying to work out what our numbers are. Now we can always confirm backwards what we should have. We should have 2400 less 150 and less 100 and less 32. 150 for the bulkhead, 100mm for the kick, and 16 for these two, the floor and the top of the cabinet. So what's that? 250. So it's 2150 less 32 is 2118. Okay, so I can check locally by confirming with my other tape measure. What I mean by locally, not referring back to the overall. So we should have 2118. Might just move that to the other side. There's 21. 2118. Let's go along to the other end, just confirm what that looks like. And you can see I have a discrepancy. It's quite a bit out. What have I got wrong? 2118 should be a correct number. What have I got wrong? And this is always the downside. That's 100. That's a bit of a fat 16. It's about, what do you call that? About 16.5mm. That's an inherent flaw. I mean, tape measures on the end, they do have a travel. That travel is not, sloppily made, although this tape is starting to get old. That travel is to compensate for the thickness of this hook. As you can see, this is damaged. What I might do is I might switch to using the 100mm mark here as my 0, right there. Okay, let's do that. we appear to be 1.5 millimetres out. We have I'll put my square over the top. It's not 18 but 16.5 millimetres. So what we have is our pencil lines are a little bit fat, and of course we've added 16 millimetres to our previous line. I don't know where that shows up. I'll just move this tape so I can get the camera closer. So these are the common errors you get when you are using manual techniques. The pencil line is always a problem. So the way to overcome that is always to refer back to here with a positive calculation, hence this business. So we have 2118. Now 2118, from the other end we had the 100 millimetre kick. I'll just write that here somewhere. 100 millimetres for the kick. Then we have 16, and then we have 2118. So the number we should be seeing on this tape measure is, in fact, this is 4, 3, so 2, 2, 3, 4. Okay. The number we should see is 2, 2, 3, 4. Let's have a look at that compared to here. We have, I'm going to call that 2, 2, 3, 3. Well, it's a bit of a lean 2, 2, 3, 3. So this is where we should be. Oh, there is where we should be. So we've got that discrepancy there, probably a millimetre. Can we zoom in on that so you can see the discrepancy? Where are we now? Just here. So a tiny discrepancy there. Now that is what our errors have been, the cumulative errors with all the pencil lines. Now I have to have some thickness of a pencil line. I can sharpen the pencil as much as I like, but there will always be, it's always a relative thing. So resolving that back to 2234 means that we're keeping our dimensions under control. And of course we know that that has to be 2250. Whenever you are putting something beside something else, you have the thickness of the pencil line interfering with the process. For this reason, when we're cutting dovetails as cabinet makers, we use like a blade to mark out the actual marks. So the centre line of the cut, if you like, is in fact the defining line that you have to cut to. So you can see, looking at that, oh, where are we? Yeah, it's about 1.5 millimetre discrepancy generated by the cumulative errors of all those pencil lines. Alright, now this also reads 150, so we'll see how we're going from the top. That looks pretty right. Okay, so you can see we need to resolve back to the dimensions as they would add mathematically, rather than just trusting pencil lines. Now the same thing would happen if we were going to set out balusters. Now I'll actually get a calculator. Here you can see my trusty, well weather-beaten calculator. Now let's say we were going to put 17 balusters along this width. I've just picked that dimension out of a hat. And we were going to have 38 millimetre pieces, so 38 millimetres is each piece. And we're going to have, okay, so we're going to have a post. Does this fit in the same image? Yes. So here's a wall, and we have balusters to go between. I'm going to use the wrong number. I'm just going to do this as a visual so you can see what I'm talking about. Dot, 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 dot. One more over here. Okay. So whatever number of balusters we have, there will be one more space. As you can see here, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then there's an extra, so there's 6. So no matter how many balusters we have, we'll have one more space. So the way to resolve the calculation is to add in another baluster over here in our thinking. So we're actually to there. So let's say, well, this was 2100 millimetres. Is that legible? Probably not. So 2100 millimetres from here to here. We have to add in our imaginary extra baluster, which will be 38 millimeters, because our balusters are going to be 38. Our total number is going to be 17 pieces. So we'll have 16 balusters and 17 spaces. So what we have to do is make our calculation include 17 balusters, 17 spaces. So the 2100 plus 38 is our beginning point. I'll use the calculator here. So we have, can you see that? Okay. So if I fit on the same space, see if it does. So 2100 plus 38 is 2138, so it's pretty simple. Divided by 17 is some ghastly number, 125.76 yada yada yada. Right, now the Casio calculators, which this is one of, if I do the same calculation, I hope I can, oh yeah, that's clear enough. So 2138 divided by 17 equals. Now if we go plus plus, there is a K that shows up here. K being for constant. So if I go 0, press the equals button, it'll add that number, the 125 point yada yada. Every time I press the equals key, it'll add 125 point yada yada to it. So it's really good for flying along and marking those numbers. So I can go 0. In our case here, we're starting at a 100mm mark. Now I'm not doing a balustrade here, I'm aware of that, but I wish to demonstrate this process of keeping our lines from accumulating an error. Okay, our kick was 100mm high. So we'll go down the other end. So in the event of us marking out, and actually no, it was 116 to here. So I'll type in 116, so 116 is there. If we press the equals button, it gives us .241. Don't think, can you read that? 241.76. So let's call it 242 for the point of exercise. I need a bit more light. But let's say that'll be our first. Now that's including one baluster and one space. Okay? Because our calculation was the 17 balusters, 17 spaces. So if I press the equals key again, it gives us 367. And if you consider our resolution to be, where are we? I'll put you over here, more light. And press, I can't keep this all handy, where am I? I'll be over here. So equals again, the number is now 493. And so as a result, I may be my pencil line out. I may be even 1/3 of a millimetre out. But I won't be accumulating a pencil line thickness every time. So by the time I hit the equals key a few times, get up near the other end. Okay, 1247. It keeps our errors minimised. Can you see that? It is there. Where am I? So that is that pencil line there. Okay, so press equal button again. That's better. 1373. And so on. So you can just go along the whole length until you've got all those spaces are drawn out. So you can see how that resolves the problem of accumulated pencil lines, because I've only got one pencil line error using this method. So this is a way of keeping pencil lines in control if you've got many spaces. Another example of where this is important, if we were doing something like a pigeonhole cabinet, where there's a lot of little shelves close together, you could set them out in the same method. Of course, I'm only doing a simple wardrobe right now, so I'm not going to keep fussing about that. But I just wanted to demonstrate that process anyway. Alright, enough of that. So in essence, going back to the bottom, we have our kick, our floor, the beginning of our door at this location. We've got the top of the cabinet. We've had a correction here. I might get rid of the faulty line. So that's been corrected. I'll draw the bulkhead in too. Now the bulkhead was the 40mm back from the front of the doors, and a further 16mm, which we can measure this method. Here we go. Oops. So that's the bulkhead. Now we can also do something to symbolise the material we're using. Now this component here, the top, will actually have a bit of an edging on it, so we can double up that line there to indicate edging, and we can indicate particle board by doing this kind of thing. Just to, how well does that show up? Very tricky, this stuff to use a camera. So you can see here, can you just zoom in a tad? Okay, so there's the particle board symbolised here. This door, I might write door here just to remind us what this is. Now this unit is very simple, and I'm deliberately using this as a very simple example. Unfortunately it's got very large dimensions, but here we have, in any case, the ability to measure physically off this object, off this drawing, with the real object. So if you needed to cut items to length, you could compare back to this view. Now again, I'm going to break up this to disguise, shorten the depth basically from front to back. So this is reasonably literal, but the depths aren't important. We're just, in this particular run, we're concerned about the height. Okay, so now I guess the next thing to draw would be just the other end, or the other side of the cabinet. Now the blades don't go all the way back, they just go to, so go between the door and the front side of the back, and the back is 16mm thick. Okay. Now you can see here's the top. Just write in the word top. Whatever you need to do to symbolise what it is you've drawn. Everyone can invent their own symbols. It's not that critical as to which way things are done. Just that you understand what you're drawing. Okay, so this is now the back. Up. And it stops here. So you can see here in this view we have the top, which is compressed, the back, which is full size this way, which is its height, the bulkhead, which is literally the correct height, plus minus how much the ceiling goes up and down, and of course we've done the other end already with the floor. So that's, in essence, because this is such a simple design, that's it for this particular view. Now what I might do behind that, I might set out the width. So again, we'll start this other end. I'll just move my tape measure to somewhere more practical. Now, as you may or may not remember from the other drawings I've done, we have a 30mm infill. So I'm going to start that here. We could get another panel, but I think I'll be able to fit this in here. I'll call this the front surface. So I'll start here. Okay. Now, the width we had with our little kludge was 570 times 4. 2280. Okay, so 2280 is nearly the same as our other bits. Now this is the width of the wall, the opening. Okay, so 2280 is here, and I'll just That's our wall. Okay, I might just make that line a bit deeper. Okay, now 30mm off that's 2250. Okay, so that's our infill from there to there. The infill is nominally 16mm thick, same as that board. So we'll okay. So then on this side, hopefully it'll show up well enough, we have a 3mm clearance. That'll bring us out to 33. And remember what I was saying about cumulative errors and pencil lines and resolving back all the time? So 33 is where I'm going to stop this. Okay, so we have one clearance here. This is infill. This is our first door. Okay. Of course, the same is true the other end. Three mm is going to be 2247. This is our infill again. Okay, so I'm going to try and explain this very clearly with a fat texter on a white piece of paper. Now, a wall opening is something like this, and it was 2280 overall. We have an infill over here of 30mm, an infill over there of 30mm, and then we intend to have 4 doors. Okay, so I'm just going to divide that up visually. Okay, so we have 30 here, 30 there, and we have 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4 doors. So we have to bring our calculation to a point where we can divide by 4. So obviously we've got the infill either end of 30mm, so that's 60mm. 60mm off 2280 will be 2220. Okay, so we've got that isolated, but we've still got a 5th space when we really only want to have 4 doors and 4 spaces, and that's each space is 3mm in width. So we'd have 2220. From here to here, we'd have 2220 less 3, which is of course 2217. But that gives us basically to that line there, from that line to that line there. Now, we've got the tape measure hooked on the Setout rod from the end. So it's basically starting on the left-hand side of this infill. So we've got to keep our errors always resolved back to what the tape measure reads. Alright, so 2217 is our dimension. Now 30 is easily recognised on the tape measure, you mark that. Then you might even do the 30, the 3mm giving you 33. So from here to here is of course 33mm. Okay, so you may choose, I don't care which way you want to go, that's up to you. Move that better into your view. You could choose to start at 33 or at 30. If you start at 33, of course, your distance will be referring to the left-hand edge of the consecutive door. If you choose to start at 30, you'll be in the right-hand edge of the first door. So it depends how your logic works. 33 was easy for me to arrive at anyway, so I'm just going to go to the far side. Okay, it's gone to sleep. Put that where you can read it with the lighting. So 2217 divided by 4 gives us the 554.25. If we press the plus key twice on a Setout calculator, it gives us this K. I'm not sure how well that'll show up. I'll try and get it in a position where you can read it. Is it going to show up? It's a very poor old calculator, very much abused. There's a K in there, trust me. It's pretty hard to see. Alright. So that means every time I press the equals button, it'll be adding that 554.25 to the number. So if I want 0, it'll give me 554.25. If I give 33, which will be this line, it'll give me 587.25. Again, it will give us 1141.5. Again, it will give us 1695.75. Now it's all measuring from this edge because it's including that 33 millimeters. So this is what's so important. It's always measuring. I might use a different colour. These numbers are always measuring back to this location, so that I'm going to say it's to there, then to there. I'm getting a bit cluttered here. Then to there, and then to there. Now there is a little bit of method to madness of going this way. This will resolve to 2280 less 30. So I want to press this key one more time. It should give us 2250. 30 millimeters off 2280. Bingo, there we are, 2250. So that has not only given us our spacing, but it's also given us an answer that we will recognise very easily. So it's given us that detail right to the far end. So we know when we get there, if it doesn't give us exactly that number, we've done something wrong with our calculation. So it's producing a lot of error correction, this method. It's getting rid of our cumulative pencil line by nature, but it's also verifying that our calculations aren't skewy. If for some reason we divided the 2220 by 4, there would be an accumulated error as we get along. Now I'll just try that. Let's just say we did make that mistake. I'll clear all of that. Let's do 2220 divided by 4. Just try and put that where you can read it. It's very difficult. Is that better? Yes, there we go. So we've got 2220 divided by 4, of course, is 555. If I started with, I'll go plus plus. If I started with 30 and went equals the 4 times, it'd give us 2250, which makes us feel like we're on that side. But the method to my madness of starting with 33, do 33, it gives us an answer of 2253, which plays no part in our drawing. There is no dimension here. So this is why starting at 33 has a merit. If you keep in your head that it has to be 2247, starting at the left-hand edge, that's all well and good. So it gets a bit tricky either way, but 33 works for me. You might disagree and think exactly reverse. That's your good business, but that works for me. Okay, so those are our numbers. I'll clear all of that and write them down on our little sketch here. Okay, I keep moving that to where my right hand works, but then you can't see it. Alright, so we've got 2217 divided by 4 plus 33 equals. So this dimension here is 587.25. Again, 1141.5. Again, 1695.75. And of course the last one is 2250. And then of course we'd go in and just mark back 3 millimeters from each one of those edges, so we end up with those gaps of 3 millimeters. Alright, I hope that was clear enough. 1696, and basically we come back 3 millimeters. Now you can go along, I'm just going to guess it for the point of the exercise. We have the infill drawn in, and we've got the end panel of the cabinet. Well, let's show now. There we go. So this is the end panel of the cabinet. or blade. I'm going to call it a blade. The lighting's a bit difficult with this camera rig. Here we go. So we've got the other blade. Okay. Now everything is concentric here, so here's the centre of the doors. The overall opening was 2280, so half of that would be 1140. That would be a very tempting thing to just use that calculation. But that assumes that both our infills are the same, so it depends where you want to go from. At the end of the day, it will produce this outcome on this job. But in any case, if you had to do something different, where your infills, say one side's 50 and the other side's, I don't know, 20, you may have to do something a little bit different. But hang on, that's a bit out of position anyway. It's very easy to get these slightly errored. I'm out by about 1/2 millimetre there. Okay. Okay, that's the division between the two cabinets. 16 millimetres both ways will give us the blades. Double checking us back to that. That looks pretty good. Alright, so now we have the two blades here. And I'll mark in some edges. It doesn't matter that much how you encode your detail, but it does matter that you know what you're talking about. So this is a door with an edging. Okay, so we can see the blades there. So in any case, we've now got the widths set out, all the critical widths. We could set out the kick if we wanted to, that would be fine, but I would probably set the details of the kick actually out on the physical kick. So that's it. We've got the width set out and we've got the height set out on this one plank. So for this view, we're only going to be drawing the depth front to back. Now the opening width, the opening depth is going to be, based on our original drawings, 177 times 4, which equals 708. Okay, so just draw that line in there. Can you see that line in there? I feel like using a very large texture or something like that to show this business. Have it turn the lighting a little bit. Is that better? Alright. In any case, that there front edge is the finished wall. Oh, don't need quite so many L's. The cabinet is set back 20 millimeters, which brings us to 688. Just going to draw the underside of the cabinet. Okay, so that's the under edge of our cabinet visualised. So this will be the face of the door. Maybe infill to the same location in this view. It's 16 millimeters thick. I might also draw the top of the cabinet just to define its height. Let's do that now. Okay, that's that. And come come back a normal 16mm, it's not important, but just so it looks about right. Okay, it's that. Now the kick was 40mm back from the face. And then actually just this way as well. That also brings us back to 56 because it's a further 16. So just do that to it. Now the kick and the bulkhead in this example was lined up. If they had to be something different, you'd actually set this out differently to what I've done here. Now remember, every dimension in this axis is condensed, not literal. So you could symbolise it with this kind of a so this is the kick and bulkhead. This is the top of the cabinet. This is the floor of the cabinet. And you may want to fill in some details like some edging, whatever you feel like symbolising it with. But the trick is to make it so it's not confusing to you. Okay, now the other end. The back is 16mm thick. And the convention I've used, it's arbitrary, this measurement, doesn't have to be anything in particular. I have simply put 550mm. I'm using the 100mm mark to measure, so I have to remember that. So 650 is the measurement I'm reading off the tape, but in fact I'm using the 100mm mark, so 650 is the important one, plus 16. It'll be fine that way. Okay, so we've got the kick here as well. Okay, so this view now isolates out the thickness of the back, pardon me. The fact that the floor and the top go over the back and the back is shorter. The blades are also in that space. Now obviously with the other view where I was showing the height would possibly include things like shelf rests or shelf locations. Maybe on one of the 3D drawings I ended up doing a set of drawers, so you might set out the drawers, drawer fronts, etc. But in any case, this is showing the depth. I guess that's something I should have said in the first place. So these setouts are only to resolve in full size one single axis, and that's quite an important detail. Well, I hope that was of interest to you, and I hope that it's useful to you somewhere down the track. Of course, this method is probably the best method if you're stuck for resources, and also it always works. Yeah, feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.